All right, hi everyone. Welcome to Chapter 6. Chapter 6 is all about the layout of your facility in order to best match the type of processing you do, the type of production you do, the machinery within the facility, where you've got your departments located, where you have your personnel located. So a little bit lighter chapter on quantitative elements to it compared to Chapter 5, which was very quantitative heavy. So you get a little reprieve from that this week, a little bit more you'll have to do on the reading side of it, a little bit less on the quantitative work. So let's get to it. Process selection basically is how you will organize the production of your goods and service. You need to make those kind of decisions because maybe you need more or less space when you build your facility, right? How you lay out your facility. You might need more capacity because you've got plans to have laid out in such a way that you want to reduce bottlenecks, and you can do that by having more capacity at certain workstations. It has major implications for what type of equipment you purchase. You might need equipment that's larger or smaller or modular in order to accommodate the type of production that you want to take place in your facility. On the selection and design, everything that feeds into it would and comes out of it, you've got your forecasting that we talked about in Chapter 3, the design of your service, any kind of technological improvements that helps you do your capacity planning and your process selection. And once you've decided on that, you then build your facilities, order your equipment, complete the layout, design the type of work you do. That's the kind of the flow through of that from the previous chapters to our current. So how much equipment and labor will be used is a term called capital intensity. Process flexibility is just determining how much you can, how much would need to change in order for you to do different things. If I need to increase volume or decrease volume, if new technology becomes available, can I upgrade the equipment that I have? Or do I have to buy all new types of equipment? Do I have to redo the entire layout of my facility to accomplish that? When you are selecting your process, for Zelda fans, this symbol might be familiar to you. Looks like a Triforce there. You need to decide how much variety will we need to be able to process through it, right? Are you a type of company that has a continuous production of one type of good, or are you something where you make custom parts, right? And so the variety within a system is going to help you determine what type of process you need to have your facility laid out to accomplish, and then at what volume will you need to be able to process it well. So you can see on the bottom two there, repetitive and continuous. Repetitive is like an assembly line. Continuous would be something like an oil refinery, where it's constantly going through there, never stopping, and it's constantly being processed. Repetitive, you've got this motion and this motion and this motion. Think of your classic assembly line with the conveyor belt, and somebody's hammering in something and somebody else is turning something over, and etc. Batch is where you're going to do think like baking a batch of cookies, right? You make a set amount of them, maybe 10 to 50 of them at a time, and then you can change things up and make some more. And then job shop at the top is, where it's just piecemeal. You are a custom shop, right? And that doesn't have to be production either. An operating room is said to be a type of job shop because every setup is different for whatever comes through there, right? So here's some examples. If you've got customized goods or service, the most customized to the least customized, you've got job shop through continuous. Let's ignore project for a second because all of this is non-routine, but the main four is what we're going to focus on here. So while that is one of them, I'm just going to draw a line down here and focus on most to least customized, right? Your job shop is going to be very customized. Your continuous processing is going to be highly standardized, right? Very efficient, very high volume, whereas a job shop is going to have lower volume, but able to handle more work, more types of work, right? Whereas continuous is only going to do one thing. So you've got kind of extremes on one end or the other, with batch and repetitive / assembly being effectively different terms for the same thing. Fairly standardized goods or service. The cost per unit is low because you're making so many of them. Very efficient, high volume, but the very high volume would be your continuous, where it's constantly processing something through it. The disadvantage of one end to the other, well, a disadvantage of a job shop is that it's slow. The cost per unit is very high. You have to plan everything out. You've got to schedule the right knowledgeable people. The disadvantage of continuous is that there's no variety whatsoever. You do this, and if you want to do something else, it's going to mean, all new facility space. Let's talk about automation. So automation is machinery that can help operate automatically, right? It has controls, sensing, or sensors in it that help you to complete the production or whatever automatically. So fixed automation, it is just, turn it on, it does this thing, right? Programmable automation, you've got some sort of computer programming, like a robotic that is programmed to do a certain sequence of options. You have to actually add something to it in order for it to be automated. It won't just automatically turn on and it does it. It's not preset. You have to program it to do the thing you want it to do. And then flexible is just a more customizable version of the programmable, in that possibly it has several different functions that it's able to do. It might have modular pieces to it that you can swap out in order for it to do different jobs. We're talking about the layout of your facility now. So how you lay out the facility is going to determine how either the production or your customers move through the system. You need to make that decision when you're either designing or redesigning facility space. Right, simple enough. Do it during the design phase. If your layout is not working, it might necessitate a redesign project. Well, speaking of project, so project are your non-routine tasks. So a major overhaul of some kind, where you bring in a dedicated team from maybe other departments or from outside in order to do this one thing. When it's done, that job is often not repeated. All right, it's just a one-off thing. But when you have excess capacity, you've got a break in your scheduling where you can address some sort of need. You can get this done. We have extra money. We can finally do that expansion we're wanting to do. We have extra time available because we got this job faster. We can maybe get this job done. We can redesign the layout of all of our shelf space in a retail shop or what have you. We're slow today. Let's do this thing. It's very costly. Often there's somebody overseeing it, a project manager, and it takes often a lot amount of time or variation of time as far as the project. Part of doing a project, and there's a chapter on project management near the end of this class, is about the planning stages of it and keeping on track with a big project. All right, back to layout design objectives when you're designing your layout. So the basic objective right here at the top, in case you're ever asked what the definition of or objective of layout design is, but facilitate the smooth flow of work through the system. That work could be material, information, what have you, but facilitate the smooth flow through the system of work, material, and information. And if you recall our definition of supply chain, pretty similar there, right? It was the flow of information or materials or goods through, up and down a supply chain that flow through a system. A lot of similarity there. Other things in the design objectives would be, avoiding bottlenecks, which we talked about last chapter, making sure we're efficiently using our workers in space. We've talked about efficiency and measurements of that, making sure that we have good quality, measuring quality service, which is a later chapter, minimize handling cost. We're going to be talking about handling and inventory cost and how high those can get a little bit later in the class as well. safety, and then morale problems. Some of the morale problems might arise when a job is just dreadfully repetitive, boring. People, want more job satisfaction, and so maybe you can build that into the design. A product layout is going to refer to the ones that match product layouts as far as the layout types go would be some sort of either continuous or repetitive layout, something that has a high flow of stuff through a system. So these are the four basic types of layout: product, process, fixed position, and combo. So let's talk about product first. Yeah, you've got either it flows from one station to the next station, to the next station, the next station. Either way, you've got a very rapid, high volume flow. So your repetitive processing, which is also known as assembly processing, or your continuous processing. Those would be types of a product layout of a facility, right? Raw materials come in, or customer comes in if it's a service industry. You go from here to here to here. You're going to example of that would be, let's say you're coming through for at the college, it's admissions day, and you've got to go from your from the registrar's office to the financial aid office to your advisor, right? All these different stations you go through, and then you're done. That's a busy day on campus when the first the week before classes start, especially if you're a new student, transfer student to NSU. Materials would be, your standard assembly line goes from this station, this part's built, now they add this to it, now they add this to it, now they add this to it, and keep going, keep going, keep going. One person's manning this station and so on, or maybe a team. We've got, so, all right, so that was product layout. This is kind of in the wrong order here. But this is examples of process types. This really should be a little bit earlier in the slides. I'm not sure why it's really located here, but here's an example of a job shop when it comes to service industry and operating room. Batch process, you're making a batch of a dozen of these desserts at a time. Repetitive process, this is an automobile manufacturer going through the assembly line. Continuous process, you've got a picture of an oil refinery there. So some examples to lean on if you're asked, what would this most closely match? Might help you to identify that. With that product layout type, the one that we were just talking about, where you either have continuous or repetitive, some of the advantages are just a high rate of output, very high utilization of labor and equipment. Some of the disadvantages are that it's dull and repetitive. It often attracts poorly skilled workers, and then there might not be a quality of output because of that skill level and that morale level, because it doesn't, it can be done simply, just because once you train on that one thing, you do the one thing over and over and over and over and over again. Very susceptible to shutdowns. So with this type of layout, because it has to go from one system to the next, to the next, to the next, if there's an issue on the third station, it never gets to the end because it has to go from this to this to this. So very highly susceptible to shutdowns. From any reason, whether it's personnel reason, you don't have enough people to man all of the machines, right? Or whether it's equipment failure of some kind, you don't have somebody there to fix it in a timely manner. Now you're shut down. You don't have the parts you need. You've got to do a lot of maintenance. You have to have a lot of capacity, excess capacity, so you can do quick repairs, and those are very expensive. So there's advantages and disadvantages, and it really depends on the type that you have. So that's product layout. If you have a non-repetitive processing, you might use a process layout. So you've got these various different departments, and they can handle a variety of different processing types. Department A can do maybe what B and C can also do. Maybe D can help out with these. And so you've got them being done by different people at different stations in batches, but there's a little bit more flexibility. So this would be appropriate for either a job shop where it's highly customizable, or when you do things in batch, so that there's a batch done here and then maybe somebody can go over here and help over here, right? So job shop or batch are the types that you would use for a process type layout, as opposed to product layout, the previous one. Yeah, here we go. All of these ones can go through different ways to get through the system. Okay, lots of arrows for this one. Oh my, I just keep clicking. There was more arrows here. Got it. All right, we've got some advantages there. There's a high variety of processing requirements, or can handle rather a high variety of processing requirements. So I need this, I need this. Well, we can do that here, we can do that here, and we've got some flexibility to help out. If there's equipment failure, usually you're able to take care of some other part of your job somewhere else, and you can still get products made, or maybe you're a customer service thing and somebody else can help out, cover someone else's area because they're cross-trained enough on it. You can, there's a little bit more job satisfaction because you've got extra roles you can sometimes do. Disadvantages, inventories can run high because you are maybe making more than you need at any one time, or having more raw materials on hand than you need so that you can handle all those different possible things you might produce. If you're a woodworking shop and that's a type of job shop, and you might have, order certain size, pieces of wood that you're not going to use for a long time just to have them on hand. There is, you need more attention, more skilled workers, because you've got people that need to be able to handle different types of products or services. Inefficiencies, another disadvantage of that type. But unfortunately, the type of work that you do really necessitates the type of layouts, and the advantages and disadvantages are just going to come with the territory. There's two other types of layouts, which would be fixed position layout. This is where the product stays in one place and all the workers and equipment and materials are moved around it. So a construction project, if you're building a building, the building floors, they don't move from department to department. You come to the plot of land where that building is being built. Right, so that's a fixed position layout. Shipbuilding, aircraft manufacturing, a space mission, right? Go to the moon and dig up some rocks, right? You go there, you bring the equipment to it. Combination layout. So some environments would be said to use a combination of things. So a shipyard, you've constantly got probably ships coming through, ships being unloaded by the stevedores on the shipyard, but there's also some custom projects that need to be done as well. Hospitals, same way. There might be some routine things that are done constantly. Office, visit your doctor, routine checkup, emergency. Okay, and then you've got in order to move away from the process layouts or specifically, people are using what's called cellular production. So your layout is set up to where you are grouped into cells, where maybe this wing of the building can handle production of product families, products that have a lot of similarity in the processing requirements. And so because of that, there's a lot of efficiency when you're not making this, that people can hop over to this machinery. Very little waste, variety of products that can be done by people that are knowledgeable about things that are similar enough that they can grasp the concepts of producing the other thing very quickly. So your service layouts, as opposed to your products, are either going to be a product, process, or fixed positions type, and whether it's product or whether it's a service that you are delivering, those layout types are still applicable. The amount of customer contact in your service industry helps determine it. So if you are A type of service layout would be, a warehouse, minimize item movement. So, getting things to where they all make sense to be able to get up to the front for the customer to buy. Retail, you lay out the products in order to influence somebody into buying more of something. You find goods that typically sell on the same ticket as one another, and you put them near each other so that if somebody sees something, they buy the other. If you go to the chips aisle at a supermarket, they will put the dips and the salsas on that same aisle, even though, maybe the ranch dip might go better with the condiments and the salsa might go better in the, with the rest of the international foods or something. But they'll put that near that, because if you buy one and you already got that, maybe you can get them to buy this other thing as well, right? Put the cocktail sauce back by the seafood department, right? Office layouts. Some offices want to increase interaction between their employees, and so they will set up, a system where the offices face one another, or have a central space that everybody walks out into, so that you interact with other employees, and might lend itself to team building. My office, in the Metallic office, is set up in a wing where you walk in, and then there's door surrounding in a little circle. So you walk out, everybody's got an area where you see each other all the time. All right, last couple slides. Let's start getting into the quantitative work. We're not going to be doing the work on line balancing, but with line balancing, the idea is, let's say you've got 2 workstations, and this one does these tasks and this one does these tasks. Well, let's make sure that the tasks that are being done are approximately equal in time, because there's fairness issues that might arise that could cause very bad morale problems. You come in, you get paid the same wages as somebody else, but they're able to get theirs done in a couple hours. It takes you all day to do all of your tasks, but you're making the same amount of money, right? So balancing out the line. Also, it's more efficient. You can have the equipment up and running for the same amount of time to get all the same 4 tasks done. But if you've got the 2 longer ones on this one and the 2 shorter ones on this one, and you're open all day, maybe you could have done everything a lot faster. So for efficiency and utilization of equipment and labor, grouping them up makes sense, especially when you start getting into scheduling, which is a later chapter, or project management. You want to be able to overlap things that take about the same amount of time, so when they go to the next workstation, they're both ready to be combined and built into the final product. All right. So here we are, we're at cycle time, and this relationship between cycle time and output rate is something where, depending on what it is you're trying to know, you can rearrange this formula how you need it. So cycle time is going to equal operating time in a day divided by how much you want to output. For example, if I say we're open for 8 hours a day, and I want to make 16 of these products a day, right? So if we're open for 8 hours and I want to make 16 of these things, well, then I need to have one of them done every 8 divided by 16, right? Which is half 0.5. So every half hour, I got to get one done. So my cycle time would be half an hour. So that's my necessary cycle time. And if I'm not making these products in half an hour or less a piece, then I'm not going to get 16 of them made, right? At least I need to average out to every half hour. Maybe I do 20 minutes for one, 40 minutes for one somehow. It still comes out to 2 in an hour, but I got to get, one done every half hour in order to accomplish my desired output rate. And you can rearrange that. If I said, how much operating time is in a day, and I divided by the cycle time, I could tell you how many I could make in a day. Okay, we were open for 8 hours a day, and I can get one of these made in half an hour. How many could I make in a day? 8 divided by a half is the same as 8 divided by 2, or multiplied by 2. So you come out to 16. All right, so 8 divided by a half, 16. So either way, it gets you back, and just rearranging that formula. So knowing the relationship between cycle time, operating time, and desired output rate allows you to rearrange to figure out the missing parts. If I told you, here's how many is the output, here's the cycle time, how many hours a day are they open? Okay, you could figure that out by rearranging it. And then number of workstations is the only other thing we're doing on quantitative work this week. Basically, it's the idea that if I have a desired output rate, then if I knew this, how long it took to do all the task times. And that's what this symbol means, this capital letter sigma to with the T. So this always means sum. If you see this Greek symbol here, it always in mathematics means the sum of whatever follows it. So the sum of all the task times, T, add all the times it takes. So every single task that needs to be done to complete one unit being built, divide that by the cycle time. How long does it take for that one unit to be built? So if I had 8 tasks and they took a total of 1 hour for those 8 tasks, and I could get one of them done every half hour, how many workstations would I need in order to get that done, right? So anyway, that's it. And we'll do a little bit more of this on the quantitative piece, but the idea is, if based on how many workstations are there, I could line balance it to where I'm doing some of those tasks here, some of those tasks here, and I could get it done. So to get one done in a half hour based on these cycle times, I would need, because they take an hour, right? It takes an hour to get all my things done. But if I had 2 workstations, then with those 2 workstations, I could spend half an hour at each workstation, and then 1 hour later, I would have 1 unit made. So we'll go into that a little bit more in the other video. This is kind of a shorter video than our normal ones. But also, one thing to keep in mind, and I'll explain it again on the other one so you don't forget it, but the theoretical minimum number of workstations, you can never have a partial. So whatever this comes out to, if it's 1.1, it still rounds up. You always round up to the next whole number. So you can't have a partial workstation if you're going to get that done. And this is a theoretical minimum. If you could line balance it perfectly, often you'll have to do 1 extra workstation because it's just not possible to, based on what you can do at the various stations or personnel issues. But theoretically, you could get 1 unit every half hour if you had 2 workstations in this example. All right. That's it for chapter 6. Thanks, everyone. Our next chapter we cover is chapter 8. We did not cover chapter 7. So I'll see you in the next video.